So 7-4 is about parabolas. Parabolas are the fourth conic section we're looking at. They are a little different than the circle ellipse hyperbola because they have only one second degree term, only one squared term. It'll either be x squared or y squared, not both. Okay, if the x is squared, then it's vertical. So kind of opposite of what you would think. If the leading coefficient is positive, so greater than 0, then it opens up. If it's negative, then it opens down. If the parabola is vertical, the axis of symmetry will be vertical. So it goes from the x coordinate of your vertex, which is this little formula here, opposite of b over 2a. Okay, and it's a vertical line. So that's the x coordinate of your vertex, and then you would plug that in to find the y coordinate. Your y-intercept will just be 0, c, because if you plug in zeros for x, the first two terms cancel, just leaving you a c. And then the x-intercept, you plug 0 in for y, and then factor most likely, or use quadratic formula. Okay, so here's the sketch of just the basic part. So this is something that is familiar. We have done this already in this class. So in this case, this parabola has 2 x-intercepts. It is possible to have 1 if your vertex is on the x-axis, or none if it's above. You have your vertex, your axis of symmetry, and then 1 y-intercept. So all the vertical parabolas will have 1 y-intercept. then we can also have horizontal parabolas. So in this case, it's the y that's squared. So opposite of what you think. If the y is squared, it's horizontal. X is squared, it's vertical. So everything is just flip-flopped here. This time, if the leading coefficient is positive, it opens right, because if it's horizontal, that's the positive direction. And then if it's negative, then it opens left. It wants to open a negative direction. If your parabola is horizontal, then the axis of symmetry will be horizontal. So it's a horizontal line, y equals, and that will give you then the y coordinate of your vertex. You'll plug that back in to find x. This time you'll have just one x-intercept, and that'll be at C0. And then to find the y-intercepts, you would factor. Or use factor. And there is that sketch. Okay, so let's practice this. So I'm given this equation in standard form, and I want to find necessary parts: x-intercept or x-intercepts, y-intercept, vertex, axis of symmetry, and then domain and range. So the first thing that I want to do is identify if it's horizontal or vertical. So which one is squared, the x or the y? The x. So that means that it is a vertical, so opposite. So this will be a vertical parabola. So we can go in the order that it's listed if you want, but I think it's helpful to start with the vertex. Okay, so when I want to find the vertex, I need to use that formula. And so I can find the x-coordinate of the vertex by doing opposite of b over 2a. So in this case, b is 12. So negative 12 divided by 2. And what is a? 3. Okay, so negative 12 divided by 6, which is negative 2. Another thing I could note, since a was positive, will this open up or down? Up. Because 3 was positive. Okay, so then back to this. My x-coordinate is negative 2. So to find the y-coordinate, plug negative 2 back in for x. So back to your original equation. So we should get negative 27. So that means my vertex then is negative 2, negative 27. Alright, so when I go to graph this, I want to make sure that I have my scale set up so that will work. I think I'll just count by 1s on the x, because I just have to go to negative 2. But then I'm going to count by 3s on the y. So negative 2, negative 27. So negative 2, and then negative 27, I want to count by 3s on the y. So 3, 6, 9, 12, 15, 18, 21, 24, 27 right here. Label that the vertex. Okay, this is vertical, so my axis of symmetry is vertical and goes through my vertex. Since it is a vertical line, it's x equals, and then the x-coordinate of the vertex is negative 2. So for vertical parabolas, the y-intercept is the easy one to find, so we'll start there. So remember, it's just going to be 0, c. Because if you plug 0 in for x, then you'll get zeros in the first two terms. So what is c? Negative 15. Okay, that's all for the y-intercept. So 0, and then again I'm counting by 3, so 3, 6, 9, 12, 15, right here. The nice thing about the axis of symmetry is that once you find one point, you can match it on the other side. So I'll go ahead and do that. I don't have to label that plane or anything, but that's just going to help me draw the parabola. So the y-intercept was 2 units to the right of that axis of symmetry, so I can find another point 2 units to the left. That doesn't have any special name or meaning. That's just, again, to help us sketch this. Okay, let's do the x-intercepts, and then we'll graph, and then we'll do domain and range. Okay, so for the x-intercepts, we have to plug in 0 for y. And then I either want to factor or use quadratic formula. This one factors pretty easy. What could I do to help make my factoring easier? Good. Factor out of 3. So if you divide both sides by 3, what would you have on the left? Yeah, it'll just be 0. So factoring out the 3 with a 0 on the left means the 3 will just end up canceling. Alright, so this factors. Now I need to multiply the negative 5 and add to be positive 4. Good. Positive 5 and negative 1. So x is negative 5 and positive 1. So that's the ordered pairs negative 5, 0 and 1, 0. Alright, let me graph those and then we can draw in the parabola. I counted by 1s on the x, so still keep that the same. Negative 5, 0 and 1, 0. 1, 0 and negative 5, 0. Okay. Now I will draw in my parabola. Alright, I want to talk about domain and range. It's been a little while since we've done domain and range. But when we have the graph, it's not too bad. So remember, domain is your x values, range is your y values. So x is an element, y is an element. Okay. So looking at x values, so looking left to right, do you have a minimum x value? No. So negative infinity. Do you have a maximum x value? No, so positive infinity. Okay, range, your y values, bottom to top. Do you have a minimum y value? Yeah, negative 27. That point is included, so I need to use a bracket. Negative 27. What about a maximum y value? No, so positive infinity. Okay. There is all the parts then. Any questions about where we found any of those? Okay, so this is parabolas and standard form. We're going to learn a new form in this section. Okay, so that is called focus directrix form. Focus directrix form. This comes from the definition telling us that distance 1 equals distance 2. Remember, the distances are from any point on the parabola to the focus and directrix. So the focus and directrix are special parts of the parabola, even though they're not actually on the parabola. The directrix is a line, the focus is a point. So this will be the vertical form. Just a bit so I can put the form here. So this is the form of focus directrix. And this is when it's centered at 0, talk about if it shifts, a shifted form, in just a little bit after we get used to the vertical form, or after we get used to just the central form where the vertex is at 0, 0. Okay, so again, I'm gonna let you write, and then we'll talk about the parts, but I want you to be able to listen, so I'll let you write this down, and then we'll talk about it. Okay, so 4 is part of the equation. So the 4 is there. P is the distance from the vertex to the focus and the directrix. Okay, the focus, so the starred piece here, so the focus will be inside the parabola. Okay, the directrix will be outside of the parabola and it will not intersect it. It's not an asymptote either, so the parabola doesn't approach it. But you can kind of think of it like an asymptote, meaning it can't cross or touch the parabola. So what the directrix will be, if you have a vertical parabola, your directrix will be opposite and be horizontal. That is why for the equation of the directrix, it's a horizontal line, so it's y equals. And then it's the opposite of the direction you moved for the focus. Okay, so if P is positive, then it opens up. If it's negative, it opens down. So just like with standard form, if we want to do the horizontal form of focus directrix, and everything, all your x and y's, everything is flip-flopped. So we're not going to have another sketch. So just think of it like the one sketch you have right now as moving over to its side. And so here is the form. Again, this is central, so the vertex is at 0, 0. wrapping one of these when it's in this focused directrix form. Oh, one thing I want you to add to your sketch, you've already had this sketch, but add this focal chord, so what's here in red, add that to your sketch, the one you just did.
Does it go through P or what?
It goes through the focus, yes.
So that's a different point than the one that goes through P.
Right. So the focal chord goes through your focus and then has endpoints. That's why it's called a chord. It has endpoints on the parabola. Okay. Now I want to practice doing a sketch in this form. Okay, so identify whether it's horizontal or vertical. So the Y is the one that's squared. So would that mean that this is horizontal or vertical? Horizontal. Okay, so horizontal. So then the equation I'm looking for is y squared equals 4px. Okay, this tells me my vertex is at 0, 0. Again, I'll show you as soon as we're done with this problem what it will look like if your vertex is not 0, 0. You would have parentheses. You would see parentheses, just kind of like with your center. All right. So my vertex is at 0, 0. Okay. This is horizontal, so I know that it's either going to open left or right. All right, 4 is part of the equation. So I want y squared equals 4px, and I have y squared equals negative 12x. So I know that 4p is equal to negative 12. That 4p, that part in front of the x, equals negative 12. So that tells me then that p is negative 3. So I needed to know p so I could find my focus and directrix. So since p is a negative, and this is horizontal, which way would this open? Left. So my focus will be left of my vertex, because that's going to be inside the parabola. So negative 3. Okay, so here's my focus. Okay, then my directrix, I'm going to go out 3 units to the right. What type of line will be your directrix? So if your parabola is horizontal, the directrix will be vertical. It's not going to cross it. Okay, and then, so my directrix is a line, so an equation. It's a vertical line, so x equals, and that's positive 3. So these are the parts that I wanted here. Technically, to make this a more complete graph, I should find another point or two that would be on the parabola. But right now I want to do just a quick sketch. I want us to really be focusing on which way it opens. So here's my vertex, and then I need to open left. So it will look like that. Again, for a more complete graph, we'd probably make a table and plug in points for either x or y to find a couple points on it. All right, so let's talk about one when they're not at 0, 0. So you would see parentheses. So here's the shifted form of your focus directrix form. Okay, again, if it's horizontal, the y term will be squared. If it's vertical, the x term will be squared. Your vertex is HK. So the x-coordinate of the vertex is always with x, no matter where x is. If x is over here on the right or the left. Okay? Your x-coordinate is always with x. The y-coordinate is always with y. It doesn't matter which one is squared. So what we're going to do is we're going to get a equation, and it's going to be kind of, it'll look similar to what standard form is, but it's not really any particular form, bless you. So I'm going to want to put it in focus directrix form. So to change forms, we're going to complete the square. Okay, so we should be pretty good at that by now. The nice thing about parabolas, though, there's only one squared term, so you'll only complete the square once. Okay. So which one is squared, the x or the y? The y. So that's what I want to complete the square on. So I'm going to keep the y terms on the left, and I'm going to move the 12x and the 3 to the right, because I'm not completing the square there. So I'm wanting it to look, you know, like one of these. So it was the y that was squared, so will this be horizontal or vertical? It is going to be horizontal. I can wait to put that or figure that out in a little bit. So I'm going to want the y squared on one side, on the left, and I'm going to do the other stuff on the right. So 3y squared minus 18y it'll be a negative 12x and a negative 3. Okay, remember when we complete the square, the number out front we want to be 1. So I have to factor out a 3. And so that'll be, I'll put my blank inside the parentheses there, because that's where I want to complete the square. So then on the right, negative 12x minus 3 plus my blank. And since I factored out a 3 on the left, on the right, I'm going to do 3 times whatever that is I used to complete the square. Okay, complete the square, b over 2 squared. So my b, I'm just looking inside, is negative 6. So I get negative 3 squared, which is 9. So I put 9 here on the right. And on the left, I'm doing 3 times 9, so I'm actually adding 27. Okay, so then my y's will factor. So what? So I put my 3 out front, and then I have y minus 3 squared. Good. Equals, and then negative 12x, and negative 3 plus 27 is 24. Okay, so remember, I'm getting closer, but I want it to look, so this is horizontal, so I'm wanting it to look like this. Okay, so my x would be in parentheses, like I want just, the only number out front I want is to be here on this right side. So for now, what I need to first do is factor out a negative 12, so I can get the x as it with a leading coefficient of 1 on the inside. I'm going to factor up the negative 12, so then I get x minus 2. So that negative 12 is on the outside. The x is just 1. This will help me identify what my vertex is. Okay, awesome. There is not a number in this form. There's not a number in front of this squared term. So let's divide both sides by 3. Get rid of that number out front. Okay, so that gives me y minus 3 squared. So those cancel. Negative 12 divided by 3 is negative 4. So then I get a negative 4 here. X minus 2. Okay, so here is the form. So that's going to just take some getting used to, knowing exactly what it's supposed to look like. So this should match up to this form here. Okay, that tells me then that my vertex is what? So the x-coordinate is with x, 2, and the y-coordinate is with y, 3. 2, 3. Okay. Now, we need to find our focus and directrix. It was y squared. I know this is horizontal because it's y squared. Okay, let's find P so we can find our focus and directrix. So I need this here to equal 4P. That's the first part of that equation. So P is what? Negative 1. So from my vertex, to find my focus, I'm going to move left negative 1 from my vertex. So then that is the point 1, 3. So this opens left because P was negative. If it were a vertical parabola and P were negative, it would open down. So since it's negative, it has to open in the negative direction. Okay, so then my directrix, from my vertex, I move 1 unit opposite of P, so 1 unit right. So it's right here. And since it's a horizontal parabola, it's a vertical directrix. Vertical lines are x equals. And that goes through at 3. 1, 2, 3. So that's x equals 3. Before we sketch our parabola, I want to find some points that are on it. So we will stop there and finish this one up on Monday. So we'll have another pretty full day of notes on Monday. So did you see how I found P?
Yeah.
That's the distance from the vertex to the focus. So P was -1, so I had to go negative left 1.